exposed to. That we don't do too much different with the circles. There's really not a lot to do with circles. Complete the square, find the center, find the radius. A little while later, we do tangents to a line with circles when we get towards the end of this. We'll do tangents to a line of a circle, and you do that in calculus. But basically, we're just like looking at this and how to tell these. There was a really good show. I forget what I was watching. It was on a kid's show, and the guy was like one of the science guys, and he actually took like solids and he sliced them. He had them all sliced up, and he showed the kids where an ellipse comes from, where a hyperbola comes from, where a circle comes from. It was on a kid's science show. It wasn't him. It was a different guy. I think he was I don't know. I think it was on Saturday. I don't remember what I was watching, but I was like, wow, this is so good to expose kids right now, because he took like a cylinder and sliced it and showed them where like the cross sections come through. So it was pretty good. He got a parabola, he got an ellipse, and he explained like how when a planet circulates, rotates around the sun in an orbit. An asteroid will make an elliptical orbit. So he explained like different things. It was pretty cool, and it was a little kid's show, so good exposure. So these are the things we're going to be looking at. Nothing that you have to memorize. Here, there, anyway. Yes. Now, you have all this in front of you. I said this is massive, massive formulas, but don't panic over them. This is your general form. You were already exposed to that. When did we see that? With the systems of equations. We were curve fitting. We found the equation of a circle. We found the equation of a parabola. So just a generalized format. We don't have to memorize that. These, you have to kind of remember this. This is probably the only thing that you have to memorize, is this. And luckily, you were already exposed to this. So I think I gave you this in your notes, right? One's going to open up and down. One's going to open left and right. If it's an x squared, that's your favorite quadratic with the x squared in it, up and down. If it's a y squared, left and right. Did you guys work with the p last year? No. To see which way they open? Well, when we did transformations, you guys were pretty sharp with that, knowing that the negative made us have a reflection, right? So that's what's going to change the direction of your parabola, is what this sign is in front of that little x minus h. So that's where the p comes from. So we're going to work on that p this year, because that's going to give us where the focus is and where the directrix is. And basically, I can't move this all at the same time, but basically, this is what we're looking at. And I can't move this over. I don't know why. I can't move it over, but you have it on yours, right? Yes. Okay. So basically what we're looking at, again, is that P is going to determine if it's opening up or down with an x squared, and that we're going to find that distance in here. The distance from your focus to your directrix is exactly the same. That's your P. God bless you. One's going to be the opposite of the other. It makes sense, right? If I'm making a parabola anywhere, my directrix is a line. It doesn't touch the parabola. So my directrix is going to be underneath my parabola. My focus is going to be inside. Yeah, anybody ever tell you, like, when you're nervous or you're scared, focus on something? Just look at something, focus on it, and take your mind off of whatever you're thinking about. Like going to the dentist. Do they ever have something cute on their ceiling? And he says, just look at the picture on the ceiling. Look at the little teddy bear, and you'll feel more comfortable. So your eyes focus this way, right? They come around like this. So they focus and they look at a point. So think of your parabola containing your focus point. All right, so if your parabola contains your focus point, your directrix has to be outside of it. And your directrix is going to be a line. So your directrix is easy. Your directrix is going to be a y equal or an x equal line, depending on which way your parabola goes. And your focus is just going to be a point inside. Now, here's the equation to find P. It's the F minus V. So we're going to talk about your vertex, we're going to talk about your focus point, and we're going to get there. However, if you're an equation person, more power to you, but it's much easier when we sketch them and work them out without memorizing. This is always the tougher one, because kids, you guys haven't really been exposed too much to parabolas that open left and right. Am I right? The y squared. It works the exact same. The focus is still inside the parabola, the directrix is outside. And again, if that's a negative, we know that negative tells me reflection. So I'm reflecting. And our axis of symmetry now is a y equals instead of an x equals. So it's not much different, and when we look at it, we really can't tell the difference by looking at it until we see who's got the square. If it's a y squared, it's going to look like that. If it's an x squared, it's going to look like that. Just let me make sure. I've got a whole bunch of notes to myself here. Okay. I have to make sure. I like to make sure that I tell you everything I'm supposed to remember to tell you here. All right, so we're going to work on this, and we're going to sketch these guys. We're starting out real basic, and we're putting them in the same form. It's either going to be this one, or it's going to be this one. And let's start with this first, because this is important. HK is your vertex. X is before y, h is before k. The x always goes with the h. The y always goes with the k. So even though we've switched these pieces around here, I switched these around, the x still goes with the h. So when I go to take my vertex out, I look for the x guy. When I go to take my y part out, I look for the k. All right?
How do you know which one of those to use?
Because we're going to tell by the square. So the first thing we notice is this is a y squared. That's a great question because this is what's going to tell us what to use. So those are the only two formats that you really have to identify with. But remember, the x goes with the h, the y goes with the k. So really, all that's interchangeable is this little piece in here, isn't it? Isn't the rest of the setup the same? Okay, so it's got the same setup, and the x can't switch to the k. It's got to stay with the h. So here's what determines what we used. Lily prompted me. So I've got a square, and it's on a y. So I go to my y minus k squared. I need to get it to look like this. So I'm going to keep this part by itself. I'm going to just subtract this piece. So it's going to look like this. Agree? Okay. Now, my equation says this. So I'm going to take out my h and k because I can. So what's the vertex of this parabola? And you guys did this before when we did your parabolas and we did transformations. You did a wonderful job in transformations. What's my vertex? 3, negative 2.
Would you
Negative 3, positive 2. Which one? Negative 3, positive 2. It always comes out the opposite, and this is why. This says negative h is equal to 3. Solve for the positive h, right? It says negative k is equal to negative 2. Solve for the positive k. So it always comes out the opposite. You probably remember that mostly from the circle, right? And don't you identify the same thing? X minus h, y minus k, isn't that part of your circle too? That's where they all fit in the conics. It will be part of your ellipse. It will be part of your hyperbola. Your circle is this. you're going to see a lot of similarities because we're going to do all the conics together. So what you identify in these pieces will stay consistent throughout this unit. When we do an ellipse, it will look the same as that. Little slight change, and a hyperbola, another just a little slight change. So we said -3, 2. Which way is this opening? Left, right, up, down. Left, right. It's a y squared. So now, we know it's opening left, right. Which way is it going to open? Left or right? Left. Why? Because it has a negative. Good. It has a negative. Just like this is your favorite x squared, this is your favorite y squared. So a transformation will flip that around. So here's the part that you probably haven't seen much, is this piece right here. So all we're going to do, I put a 1 here just so that you'd see the number here instead of a negative. So -1 is equal to 4p. So we're going to solve for p. P is equal to -1/4. That means from my vertex, it's going to move 1/4 unit over both ways from the vertex. Inside gives me a focus, outside gives me a directrix. Okay? Without using, we haven't used any of those formulas, right? We didn't use any of those x minus y's, y plus k, blah, 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 blah. We didn't use any of those. So we're going to sketch this guy. We're going to start with our vertex. -3, +2. We said it's opening left. Now, I don't know how wide yet, so obviously my intercept is going to play a point here. We're going to have to talk about an intercept in a minute. But my goal here is we've got our vertex, and we know what P is. My focus has to be inside here, and my directrix has to be outside here. Okay? So if I move horizontally, I'm moving horizontally. This is my axis of symmetry. Okay, what's my axis of symmetry? Y equals 2. On this guy, isn't it whatever the x value is, x equals something? So this guy is whatever the y is. Y equals 2. Simple, right? Don't memorize. Get a feel for it. So now, I need to move 1/4 that way. So what's my focus point going to be? -3 1/4. Good. And I need to move this way. Is this line going to be an x equal or a y equal? X equal. So just give me the x point. You're moving horizontally. I don't care what my y is. It's going to be the same, but 2 3/4. So x is equal to -2 3/4. If you want to flip that to an improper fraction, it probably looks a little bit better. Okay? That's all there is to it. That's it.
I don't know if it opens left or right.
By this negative. By this negative guy right here.
What would make it open right?
Positive.
So it's just the H number, or just the H matters?
No, the H comes from the vertex. The H and the K give me my vertex.
Yeah.
So let's take a look at your old beloved one first. Okay? Let's take a look at this guy. Opens up, agree? How did you know this opened up? Pretend my vertex is here at the 0, 0. Because what's positive? The number in front of x is positive, right? Where does this guy open? Down. So now let's reverse our thought a minute. I'm going to do a y squared. My favorite y squared is just this guy, my normal y squared, because this is positive. If I'm negative, isn't it just a reflection? If my y is going to change, I'm just going to get a reflection. It's going to go this way. I'm just going to reflect. Okay, good. Those are good questions because it's basically all we have to do. Yeah.
Why does the negative have to be on the x then? If it's
because it has to follow that format. This is vertex form. So this negative has to be out in front of this set of arguments.
So, like, we're saying for the x equals y squared, in order for it to flip, it has to be x equals negative y squared. Then why wouldn't the y be negative?
I'm not seeing your question.
I'm
Am
just
I?
confused.
Yeah, I know, and I'm try again because I'm not seeing what you're asking me.
When you're giving the example, you did x equals y squared.
Yes, yes, and your y was negative. We went from positives to negatives, right? We did when we took the negative, we did a reflection over your x-axis, right? So, but over here, this is where your y squared is. So if I put a negative here, aren't I really negating my x? Your equation's backwards now. Where's my y squared? My y squared is here. If I took this and I negated this thing in front of it, my y stays the same, doesn't it? What's going to change is my x. So my x now is going from positive to negative. You changed this around a little bit. Hang on. 1 sec. Let's graph. Okay, let's graph this. I can't graph a y squared, but I can if I do it in square root and do two things. So if I took the square root of this, and I said square root of x, and the negative square root of x. This is technically your y squared. Okay, it goes like this. So what happens is now, if I go to take the negative of this, I'm going to cause it to reflect this way. Because if I come outside of my equation, instead of changing the y value, I'm going to change the x value. So if I looked at my table, and I went here and I changed all my x values, just my x values. So just like take this guy, just start changing one of these guys. I'm not changing my y's, my x. So what happens when I change my x? These all stay the same, don't they? But aren't I on the other side of the axis now? So it's a reflection in the y-axis. It has to be the opposite because look where your axis of symmetry is. Your axis of symmetry here is this way. Your axis of symmetry here is horizontal. And that's a great question because I'm still negating this, but it negates this guy, my x. Good? Kind of seeing this question?
I don't get exactly -2 and 2 fourths. They're like
Okay, so your P, your point, your focus is inside of your parabola. It's P distance away here and P distance away here. That's why P is important. P is what actually finds your focus and your directrix. So before you guys were like looking at it as a transformation, okay, it's negative, I know where to reflect, I know where the movement is. I go the opposite in here, -3, I go the opposite here, 2 up. But this guy here plays a strong part. This gives us P. This gives us our focus and our directrix. If you go back to the original equations, I don't even memorize them. If you go back to the original ones.
So why should you write it as x equals like why wouldn't it be equal? Oh,
because it's the opposite. It's a y squared.
Yeah.
It's a y squared. I know you guys aren't used to seeing y squared, but you'll get used to them. If I did this, let's go back to your formulas for a second. Here's my vertex. Here's my directrix. It's got to be an x equals, doesn't it? Whoops. Here's my x squared. Here's my directrix. Here's my focus. These are the formulas. Let's look at your formulas for a second. This is why you don't have to memorize these, because watch. Your directrix is a line that goes like this, right? Let's walk through the steps how you got this. You took which one of these, the x or the y, and subtracted 1/4 or added 1/4. You took the x. So look what it says. Take the h value, the x value. This is h. Stay with me, guys. Just stay with me on this. Take the x, which is your h, and subtract p. So if I take this and I subtract p, this is -3 minus a -1/4. See my equation? move backwards. But do I have to memorize this equation? No, isn't it easier to look at this and say, just go back 1/4? So now when we get here, your focus. Here's your HK. My H is -3. My K is 2. Didn't we say this is going to only change my X value, my H? And what was I going to do? Go 1/4 to the left, right? So look what it does. Plus -1/4. Isn't this the exact same that we did? Without using the formulas? I find the formulas a little tougher to use. If you like the formulas, by all means, use them. They work, but you still have to kind of figure out which one are you using, the X or the Y value, before you can figure those out. So, kind of get a good placement. The only other thing that we need here is an intercept. An X-intercept and a Y-intercept. Okay? So this guy's going to have an X-intercept. So to find the X-intercept, what do we set equal to 0? The Y. Good. So if I set this equal to 0, I'm just going to hold my hand over this, because this is 0. What is my X-intercept? -3. Okay? So isn't it pretty much crossing about the -3? Whoops. Can't cross it, the -3. Oh, I'm sorry. This is my fault. This is not 0. If this is a 0, what does this become? 4. So if I subtract this, and I get -4. So if I subtract 3, I get -7. Does that make sense a little bit better? Yeah. Okay, so here's my y-intercept, my x-intercept. My y-intercept, if we don't have one, it's just the opposite. Do the opposite and you'll be fine. And you take the square root of that, it's 0 anyway. Okay? The y squared is going to be a little bit different. But just work it through. Find your pieces each time you go. Let's go to your favorite x squared. Okay? All right, now, this is an x squared, so we've got to use this format. I know this is nice to graph off of, but we need this format. So what should I do? What's my vertex on this? Oh, 0, 0. So it's okay with you if I just do this first? Just so that you see where the x and the h are, the h and the k are. So am I in the right format for this? Does it line up to what it's supposed to line up to? Yeah. Yeah, it does. My x usually works okay. It's my y that's a little bit fishy. Does this line up to this? So, what's it supposed to line up to? Is that the way it's supposed to look? No? So what am I going to have to do? Come on, work with me. I got this, but where does that belong? Look at your format. Look at your equations. We only have 2 to memorize, guys. This. Okay, we got to work with it. But my x works a whole lot easier than my y does. So what do I need to do? Okay, let's just do this first. Am I allowed to do this? What property is that? It's not on the same side. When I switch over the equal sign, what's your favorite one? Reflexive. That's reflexive. Am I allowed to do, when you do a line is reflective, it's equal to itself? I'm just switching it around. So what's my biggest concern now? The 2. What am I going to do with this 2? Okay. If I divide by 2, what am I actually dividing by 2? what's in front of this? What's the number in front of this?
1/2.
Now this number makes a difference to us.
That's the P.
That's the P.
So why do we have the y minus k on the other side for that part?
Because you gave me the wrong equation. I wanted to write it like this so that you would see, I wrote it like this. I wrote it like this so that you would see, does this match up to what it has to match up to? Is this where my equation should be? I've got all the pieces. I've got all the parts that I need. It's just not in the right order. We're just changing around your lovable y equals x squared. That's all we are. It's just changing it around. We're making it look like this. I put the zeros in there so that you would see where the h and the k are. I thought maybe that would make life a lot easier. It's actually probably easier without the h and the k in there, but I just wanted you to see where the h and the k come from. So now, what do I need to find? I know what my vertex is. I need to find P. So let's set this equal to each other. What do I solve for P? Divide by 4, all right? Keep change, flip. One eight. You guys are confusing me. You guys have such a hard time with fractions.
Is that wrong?
No, it's right. But it's like one step at a time. 1/8. Yeah. You guys hate to see a fraction.
Yeah, I don't get anything.
Okay, so we know what your P is. We know what your vertex is. Which way is this going to open? Well, it opens, okay, up, down, or left, right? And where's the square? X squared, this is your beloved formula. Where does this open? Look at the main one. Where's it opening? Up. And what else tells me that it opens up? Positive where? In, no, not in the X. Where's the positive? Shh. P. P is positive. P tells me which way I open. But don't you know from this guy here anyway? Which way is it going to open? What's that 2 going to do? Make it a little narrower. It's going to stretch it up, right? Isn't this part of your transformation? So now we have a focus in here. Where do we find our directrix? Below, somewhere below this line. Is it going to be a y equal or an x equals? Okay, when I do this, my focus, am I going to change off my x or off my y? If I'm moving up and down, which one's going to change? My y. So let's start with your x. And how are we going to get the y? Add 1/8. So this becomes 1/8. Is that okay?
Yes.
Okay. This guy's going to drop down. Which one do we care about, the x or the y? Okay, and what are we going to do? Y equals what? Subtract 1/8. That's it. That's it. This is your directrix. This is your focus. This is your vertex somewhere. Oh, vertex. You told me everything you know about your parabola. Where your vertex is, where your focus is, where your directrix is. But it came from this. Could you tell me what your focus is from here? If I had it in this format? Let me cross this out. So let me look at that. Now remember, I don't like to memorize a lot, but these are the 2 things that you have to memorize. When I get here, I know this is correct. I know I'm in x squared, but I'm still confused when my x squared is over here. That's not my p in front of this with the square, is it? So I got to move these around. I almost got it to where I need it. So looking at it like this, and it's probably easier now that you can see it without this. if I looked at it like this, do you recognize this is my 4P in here? And this is a 0, 0 anyway? I wanted to put the H and the K in there so that you lined them up. Okay, now on the homework,